Okay, so I'm going to talk about the iCASP Enhanced Surface Water Flood Forecasting Project and the impact of iCASP on national forecasting services. This talk is a joint effort between myself, so I'm Dr. Catherine Birch, I'm an Associate Professor in Meteorology and Climate at the University of Leeds. And I'm going to give a recap of the aims of the iCASP Enhanced Surface Water Flood Forecasting Project and just go over the outputs and pathways to impact of that project. Then I'll hand over to Graham Boyce from the Flood Forecasting Centre in Exeter, who will talk about another project called National Boosting Action on Surface Water and a DEFRA initiative for enhanced briefing capability for the response community. So surface water flood forecasting is challenging because the convective storms that predominantly cause surface water flooding are hard to predict in weather models, although in recent years there have been advances in forecasting capability. In this iCASP project, we wanted to test the feasibility of combining the latest probabilistic rainfall forecasting and high-resolution surface water modelling to try and create useful sub-county scale surface water flood forecast maps. And the project had three main parts. We firstly reviewed current surface water flood forecast and response processes within Yorkshire and nationally. We then developed the enhanced flood forecast maps, and then we tested them through a user workshop. And this project is now 95% complete. We had the workshop last year, and now we're just working on maximising the impact of the project, which of course is the most important part. So existing impact pathways for the project are, we've published the results from the project in several industry magazines, so in the Emergency Planning Society magazine and the Environment Agency magazine. And we've also communicated the results to people such as the Flood Forecasting Centre through a visit, and also to local forecast users and flooding stakeholders through events such as the Yorkshire Flood and Coastal Committee workshop. The iCASP report for the project was published almost a year ago now in 2019, and that's available from the website. And to date, 21 different organisations have downloaded the report. There's also 2 academic papers. There's one that I'm going to submit by the end of this month, which is a outline of the entire project, and then there's a second paper which has already been submitted on the more technical side of developing the new surface water flood forecasts. So these are the recommendations from our project. First of all, we suggest that we need to provide local authorities with additional support for surface water flooding. So there is, of course, a need for better forecast information, but also local authorities lack sufficient resources to respond proactively to heavy rainfall events, particularly when the rain is forecast over weekends and holidays. So the lead time for these forecasts is often quite short, so often these forecasts, say for a Sunday, can be missed, or the forecasts don't exist on a Friday in time to take proactive action. The second recommendation is to encourage decision makers to make better use of the existing static surface water flood maps. So ultimately in our project, we found that the new products that we developed were probably not the right option due to the amount of computing time that's necessary to produce them operationally and the uncertainties in the rainfall forecasts that go into them. But it could be better to use existing surface water flood risk maps alongside the probabilistic rainfall forecast to give responders a better idea of where significant flooding may occur. There is, of course, always the need to systematically evaluate new forecast products, but this definitely needs to be done in conjunction with users. So we need to further engage with the community of Yorkshire forecast users. Our iCASP project focused on forecast lead times of up to 36 hours ahead of time, and the products tested on the group of Yorkshire users was very much at the research and early development stage. But recently, the Environment Agency and Met Office have engaged with the same group of users to test out new nowcasting products. So these have a much shorter lead time. So these are products that are forecasting just up to 6 hours before the event. And these are relatively much closer to implementation than those in the iCASP project. So now I'll pass you over to Graham, who will talk more about the nowcasting products and testing.
Thank you, Catherine. I'm Graham Boyce and I work at the Flood Forecasting Centre in Exeter, and I'm currently leading a piece of work on behalf of both the Environment Agency and the Met Office, which has its origins in DEFRA's Surface Water Management Action Plan, published in July 2018. DEFRA, through its Surface Water Management Plan, has tasked the Met Office and Environment Agency to scope the development of a new capability for sharing with responders very short range and rapid update forecasting or nowcasting information for the type of rainfall that causes surface water flooding. We started this work with a discovery phase. There were effectively 4 key elements to the discovery phase. We firstly reviewed the current landscape to identify any learning and related initiatives. Perhaps the most important, we looked to identify user needs of responders, working with Category 1 and Category 2 responders, including iCASP members and central government. The main activities of this was to review existing user research information, to undertake user research interviews focusing on responder context and behaviour, how information is currently received and how the responder approach could evolve if more information was provided, a structured questionnaire, and some user and usability testing using mocked up information products to determine whether these were usable and valuable. We worked particularly with the Met Office to identify existing and near future sort of nowcasting information. And we also considered existing delivery methods and systems that could be used. I think it's important just to stress what this work isn't about. It's not a new warning service. It's not in itself delivering an operational service. It's an exploratory piece of work. It's not dealing with the public. We're not engaging directly with the public. It's about surface water, not rivers and sea flooding. And it's not looking at new ways of modelling or future surface water flooding or assessment of risk. It's about sharing information that already exists. In terms of the discovery phase, which we completed in March, I've listed here some of the findings and recommendations. In terms of findings, the effectiveness and efficiency of the responder community action does have a dependency on the quality of information they receive, and there's a clear need and desire to have as much information as possible. This puts responders in a stronger position to take decisions. With the enhanced briefing in mind, user feedback suggested there would be considerable variation in the possible action taken given the short timescales, and therefore the emphasis is likely to be towards communications, sharing of new information, and perhaps continued monitoring rather than active response. There is, however, a clear need that the users indicated to know when it is safe to respond. That said, the benefits are difficult to quantify, though we believe there are some real intangible benefits to exploring this further, which are included in the slide. As I said, whilst there's still work to be done to better understand potential benefits, based on the findings to date, we recommended that the project should proceed on a sort of 2-stage alpha or testing phase. First of all, conducting this sort of testing phase will allow additional opportunities to confirm user needs and allow us to shape any proposed enhanced briefing capability. And the intent is to take a low-risk, step-by-step approach to test various product and delivery permutations and then carry out additional user testing as we do so. Importantly, remaining aligned with the work the Met Office are doing on nowcasting forecasting. As I had previously suggested, our discovery phase was completed in March, and unfortunately subsequent to this, like many things, our project plan has been impacted by the coronavirus pandemic. And while our alpha phase was due to commence in March and then run through to this September. We had proposed using the initial alpha phase to learn more about the user needs using low fidelity prototyping based on test data and exercise through model office approach to help us create an end-to-end prototype ahead of the UK or this summer's convective season. This allows user testing to proceed in a safe environment, hopefully revealing the effectiveness of the proposed business change. And it can also reveal limitations of business processes, can help develop knowledge amongst participants, and hopefully provide a demonstration of the capability and encourage buy-in. So whilst we were able to do some preparatory work for the model office, planning both face-to-face and online sessions, due to the current pandemic, we've suspended or put on hold the alpha phase of this work with a view to restarting it when our user community, people like yourselves, have perhaps the space to contribute to and support it in a more focused way. So we paused the work in mid-May. We're reviewing it regularly, and our current thoughts are that we may be able to restart in September at the earliest, but again, this may be later. And on this basis, we've proposed that our pilot phase that would have taken place this summer will have to be delayed till next summer's convective season. We are waiting for some confirmation as to whether budget will be available for this, so there's still some uncertainty. In the meantime, our delivery team has been reassigned and we'll reconvene that team when we are ready to restart. If you want any further information, please contact me. I'm the project executive, or Alex King, the project manager, and our details are shown on the slide in front of you.